Guys, so in this video we're going to be talking about how to write a system as a matrix equation. So given a system, we want to write that as a matrix equation. So remember that our matrix equation looks like this, where A is the coefficient matrix, X is the variable matrix, and B is the constant matrix. I always forget that one. Constant matrix. So the coefficient matrix is first, so we're just going to take the coefficients. So before you start doing this, make sure that your variables are lined up. So x's are with x's, y's are with y's, and so on. Because then that makes this really easy, because then you just look at it and you just write in your coefficients. But if they're not lined up, then it's just easier to make mistakes. So sorry, that's a little sloppy, but there's the coefficient matrix. And then your variable matrix, again, is going to be in the same order. The order that they're in, left to right, you're going to write that top to bottom. So this is going to be x, y. So in other words, if I wrote yx here, that would not be correct, because if I multiplied these two together, if I had y and then x, then my x's and y's would be switched. So we want to make sure that we have them in the correct order. Otherwise, our solution is not going to match the actual solution of the system. Right? And then our constant matrix is just whatever the constant is on the right side of the equation. So this is the matrix equation that represents this system of equations. So doing that again with this one, we're just going to have the coefficients. This has a coefficient of 1, right? The variable matrix xy, and the constant matrix. All right, now let's look at the same thing, but with 3 equations, 3 unknowns. So these are in the correct order, A, B, C. I mean, they're all in the same order is what I'm trying to say. They're not exactly lined up, but we're just gonna, so I don't have to rewrite things, we're just gonna pay attention to where things are. So A's go together, B's go together, C's go together. So it's going to be the same deal though. Coefficient matrix, so 5, 1, negative 4, 3, 1, negative 1, negative 5, negative 2, negative 6. I would, if these were out of order, like if I had B, A, C, or something like that, I would rewrite it just to make sure that I don't confuse myself when I'm writing this, because they need to be all in the same order when I'm writing this out. So if your variables are not all in the same order in all of your equations, I would go ahead and rewrite the equation. Okay, then the variable matrix would be A, B, C. Same order as it is from left to right. And then constant matrix goes like that. So it's very much the same thing. If there's ever an equation where the one of the variables is missing, if one of the variables is missing, then you'd put in a 0 wherever that happens. So if this negative c wasn't there, then this would be a 0 right here. But yeah, so these are exactly the same, and they can be solved in the same way as well. You would multiply both sides by the inverse, or multiply this by the inverse. I'm not going to make you do that, because finding the inverse of a 3 by 3 is kind of a pain. So it can be done, but I'm not going to make you do that, The mechanics of solving this are exactly the same as with a 2 by 2. I'm just not going to make you do it because it involves finding the inverse of a 3 by 3 matrix, which can be time consuming. So we're just not going to do it. Okay. So, and then this would be the same thing. I don't think you need me to do another example of that. So that is all we're going to do in this video. And then in the next video, we're going to do this and then also solve. So hopefully that helps. Let me know if you have any questions, and I will see you in the next video.